Hi everyone, I'm Rupali. This is my first time presenting at an external event, so please be nice. So the topic of my presentation is data-rich marketing at King. I'm basically going through other people's projects and then some of my own. So I put this slide in here. It's the agenda because the last time I did something like this, one of my colleagues had a feedback that he was really nervous throughout the entire thing. He didn't even know what I was going to talk about. So here's what I'm going to talk about. I'm going to talk about myself. I'm going to talk about my team at King, then a little bit about market mix modeling. I'll get into what that means later, if you don't know. Then a bit about my model, which is called short-term attribution model, and then potential shortcomings and like improvements for the model as well. So about me, I graduated from LSE in 2014. I studied financial statistics. I did not go into finance because it was, well, really boring and difficult. So I decided to come into marketing instead, which was a great decision. So I joined a company called Data to Decisions, which is a marketing consultancy where I did a year of like econometric modeling for different industries like fashion, banking, a bit of tech, all of that. Then we came to Sky, and here I spent about 2.5 years in their econometrics team doing more econometrics, obviously. And finally, we're here at King. I joined King in February 2018, and in a team called Central Marketing Analytics. That's them this week, all of us, very drunk at 1 a.m. at the marketing offsite. I put this picture in here to embarrass them because they were all going to come, and then none of them showed up, so actually the joke's on me. But it's fine. I can live with it. So why does marketing need us? So I'm going to go into a little bit into the kind of projects that we do here. Forecasting return for every new player. Let me explain the model to you. So I'm not sure how many people here are from marketing. Okay, one person, 2 people. Great, a few people. So in case you don't know, the way digital marketing works is it's like a bidding system. You kind of tell them what quality of players you want to buy, and you give them like a cost that you're ready to buy at. But you don't know if those people are going to pay off, obviously, because you're basically betting on their lifetime value, aren't you? So we have a model in our team which basically predicts on their 4-day activity what kind of return we can expect from them in their lifetime. And that's how we keep revising our targets, and that's what this model does basically. Now, I don't work on this model, but other people do, and if you're interested, I can connect you guys. The next one is quantifying impact from all marketing channels. By this I mean not the digital channels, because in digital you actually know it's a one-to-one connection. If you click on it, I know you came through a digital channel, so I don't need to model that, right? But I do need to model things like TV or social or PR, because there's not a direct connection as to if you saw a TV ad and you bought my product, but I don't know that you actually saw the TV ad and that's why you bought my product. But the reason it's important to quantify the impact from the channel is because how would I invest in it in the future if I don't know what kind of return on investment am I getting? So that's the model that I work on currently. And finally, the last thing that we do is also very important, which is communicating insights to the business using data visualization tools. So the tool that we use is Looker. It's kind of like Tableau. And a lot of our time is spent on that tool as well, building dashboards and stuff to be able to communicate all our insights to the business. I also did not say this before, but if you have any questions, please pause me right away because it's better that way. So like I said, this past year, most of my time has gone to that guy, which is quantifying impact from all marketing channels. By this, I mean linear TV. Now, linear TV is confusing. I just mean normal TV that you see. The reason I wrote linear TV is because it's not stuff like Netflix or Amazon Prime. It's not on-demand TV. It's just TV you see on the networks. And also these guys. So social and PR, we all know like the activity King does on Twitter or Facebook or LinkedIn, whatever. So we want to know how many people get influenced by that kind of activity as well. And there's platform featuring. Now, if you don't know what platform featuring is, it's if you go into your app store and you go to the games tab, sometimes Candy Crush shows up right there, right? That is not by accident. We meant it to be there. It's not an advertising channel per se, as Google or Apple people would tell you. You're not allowed to pay for it. It's something they do for you. It's kind of like a favor system. It's pretty cool. But we just want to know. We'd really work hard to be on that app store, and we want to know if it's working. Otherwise, all that effort is completely futile. So that's what I work on. I want to know if these channels are paying off. Oh, wait. So how do we do it? So the way industry does it, and the way I've done it in the past, like 4 years before I came to King, is using market mix modeling. What is market mix modeling? If you don't know what market mix modeling is, it's a very elaborate linear regression model. It's not just, sometimes you can use log linear as well, but mostly what I've used in the past is a linear regression model, and it has a lot of data that goes on behind it. So the objective of a market mix model is to split out all of your installs or sales or whatever you're modeling, your gross bookings, split it out on a daily, or it's a time series model, so split it out on a weekly or a daily level to see what is driving your sales. Is it price? So I have a graphic. So this is your base level of sales. This is what would happen if nothing changed in the market, ever. You did not do any promotions. Your product just sat in Tesco's, just sitting there. You did not do anything to promote it. Nothing happened. It's all static. But what if price increased? Your sales would go down. What if there were some economic factors affecting it? Inflation, all of that. What if you did some offers in the market? You could add additional sales. So this is like kind of the output of an econometric model, which is that it builds up all of these factors on top of each other. So you can see exactly how much your competitors are taking away, how much your seasonality is adding or subtracting from your sales. So this is the kind of thing that we try to do using a very elaborate econometric model. Is that clear? If you're wondering about the kind of variables we use, then as it shows, as a dependent variable, you use whatever, sales, installs, whatever you're trying to model. As your regressors, the kind of variables that you're looking at is your price, or the discounts that you did in the market. So all of that, just put it in there and see what effect it has, see what the coefficients are, see if they make sense, what the R-squared looks like, all of that. Right, so it does make sense. So if we were to break it down, the model into the simplest terms, and if you just think about a regression model with one variable, then you're kind of saying how is your installs affected by your price. Just put price in there, see what coefficient it gives you, along with the base. And then you can make a decomposition out of it, by which we mean multiply the coefficient by the actual variable to see that, exactly that. Does that make sense? Yeah. Cool. I'm glad you asked that. Okay. So yeah, there was one left. But obviously, there are a few pros and cons to every model, and this model has some pros and cons as well. Which are, so the pros first. Let's go through the positives. It is a very stable model. Unlike a lot of models, econometric model has a lot of work that goes on behind it. It is it is throughout a very long period. You're modeling a very long period, so you have a lot of data points basically. And if you've done it well, in the next update that you do, which is if you refresh it for another year or half a year, things shouldn't change much. You should have stable coefficients. You should be still telling the same story, and that's how you know you built a very reliable kind of model, and you can be proud of yourself. And also, the good thing about this is also it gives you a holistic view of all marketing activities, by which we mean you don't have to build a different model for each of the factors that you're trying to estimate. You don't have to build a different model for price, or to see the impact of price, or promotions, or any of the media activities that you did. It's not individual, it's all in one model, and you can see how all of it is interacting with each other. But cons. It is very modeler dependent. You can, and people do, mess it up. which means that you can manipulate the results by manipulating the variable that is going inside it, which is not ideal, because then you have no way of checking, and it will show, like next time you update it, you will have problems, and that's when you know you haven't done it right. Does that make sense? You can, because basically any regression model is as good as the data that goes into it. But if you have messed up the data, then the model is not giving you reliable results. And finally, models take very long to update. So when I worked at Sky, we used to do one update after the other. So all of our time, one quarter, as soon as a quarter finishes, we used to update that quarter's model, and by the time we're done, which is like 3 months, we are on the next project. So it does take a very long time to update. It's not just the data part, but to create a stable model, it takes quite a while, and that's why it is not ideal. And often at King, as people might tell you, they want a quick answer to everything. They want to know the next day what happened. That's why we have an alternative. And we call it the short-term attribution model. It used to be called the TV model because TV is all we did, but now we kind of updated it a little bit and it can do other things. So we call it short-term attribution model. And at the core of it, I'm going to try to explain it. If anything is unclear, please stop me and ask me questions. So what we're trying to do here is, for example, I want to model installs in the US. I want to see how many people are downloading Candy Crush and what is the impact of media on it. Now the basic underlying theory behind this model is this. King games are played in over 200 countries, right? So there are a lot of countries, there are a lot of other countries that are also playing your game apart from the US, and the underlying assumption, and what you're trying to do is this. Okay, so imagine this is US sales, that's your time series, right? And we try to create a baseline level of installs using how the other countries are behaving. So we take countries that are similar to the US in terms of their seasonality or behavior, like how they behave, and we take those countries, we put them in a model, and choose and create this baseline based on those countries. Now, how does the model choose this baseline? How does the model know which countries to choose? It does that using lasso regression, where we give the model around 20 countries. We give it 20 installs in 20 other countries, for instance, and it would choose a parsimonious model based on what fits best. So in this particular scenario, for instance, it has chosen Brazil, Colombia, and Peru. They sound all right. And then, on top of that, we have built the baseline plus media. All this is imagine a regression equation where first you just put the countries in, and that's when you get the green line. That was the actual baseline. And if you put the media in as well, that's when you get the pink line. So TV only ran. Can you actually see the green?
Yeah. Yes.
Yeah? Okay. I mean the green block. Is the green block visible? Okay. It was visible on my laptop. It's not on this. But basically, that's the area where your TV is running. And that's the only place where you see the difference between your baseline plus media and baseline, right? Is that vaguely clear? Is that clear? Okay.
So you did not run the media in Peru, Bolivia?
Yes, exactly.
That's the difference.
Yeah, that's the difference. So we only ran media in the US, and that's how we were able to baseline. Yeah. Now, what are some pros about this model? It's a great model, and the best part is you can analyze any number of local activities if you have the data. So by which I mean, that was an example for TV in particular, but you can actually put in social impressions or PR impressions or platform featuring impressions that we tried to estimate as well. And we can analyze any number of local activities as we want. Also, the model can be used outside of marketing. It is a very basic principle if you think about it. And if you have a time series that is specific, one time series that is specific to every country, you can baseline anything, really. So if you guys do not work in marketing, I'm sure you can find uses for it in other fields as well. And finally, the model is quite easily automated because I wouldn't say it's completely unsupervised, because every time we get an output, we do need to check it. Sometimes it just does not say the right things. But It is fairly does its thing, and the system that we have currently runs over 70 models in less than 15 minutes, which is quite convenient. And so you can actually look at the outputs of every model, see if they make sense, see what you want to iterate on, what you want to model again, what you don't want to model again, and that's it, you're done, and you have an answer, at least for the short term. There are some drawbacks, obviously. I'm going to pause here. Any questions so far? Yeah.
So this is very naive, but I don't quite understand how the American baseline, how the other countries serve as an American baseline without advertising. Because wouldn't America just have a much higher level
You're right.
anyway? Or is the model looking at changes, and that's why you can use?
So America is a higher level, but what we're talking about is if in the short term, for one weekend, you probably ran a TV campaign or a social campaign, right? What the model is doing is assigning 2 or 3 countries a coefficient to be able to model American sales. And what you're really trying to capture at the core of it is the seasonality impact. Because there are factors that are happening in the game as well as in all of these countries. For example, those uplifts that you see here, sorry, can you see it? Yeah. Those uplifts that you see here are actually just like weekend uplifts. So obviously people play more over the weekends. So that's the kind of thing that you're trying to capture here. And the countries are able to do it. So you have captured seasonality, and on top of that, you build the impact of media. Is that clear?
Yeah.
Yeah? Okay. There are a few drawbacks to the model, like I said. The model is a very short-term model, and it's a short-term time series model. And as you would expect in any model that does not have many data points, it can really change if you even change the time period by a couple of days. So sometimes it can be difficult to establish a reliable baseline. It's okay if it changes a little bit, but it does send red signals if it changes too much, which is when you know that probably the approach that you're using is not right. Maybe the underlying assumptions to the model are not right, and maybe you should be thinking about other ways of estimating how much your media did. And secondly,
just one question. And the model is based on getting a subset of countries, 4 countries, and then is calculated. Do you have any strategy to compare the result with different groups of countries, so I can create multi-sets, and also in erasing one of the variables in the camp? For example, I started from a set of 4 countries, and then I try to remove one of them and to see if 3 countries are giving a result that is very close to. What is the difference in the results in doing this kind of operation, reducing from 4 to 3, just an example, or producing different set of 4 and producing the result? I mean, if we see big difference, the model is not reliable. If we see small difference, the model it is. What is the real case in this case?
Yeah, so we have tried that a few times, and usually what we do, as I said before, it's like we use lasso regression, right? So that's what automatically selects the group of countries that it wants. So we give it about 20 countries, and then it chooses itself which 3 or 4 countries are the best correlated. And you are likely to get the same results every time. Even if you remove a couple of countries, it usually comes back with very similar results. Like sometimes we do remove countries. You're right. Yeah. And additionally, the other drawback of the model is that it cannot quantify the impact of global activities. If you ran a campaign through the world, you cannot measure the uplift using this approach. So, potential solution, one of the things we tried this year was seasonal ARIMA model, because if you think about it, all you're doing with the baseline country approach is you're trying to estimate seasonality, right? And there is another way to do it, which is using ARIMA. And ARIMAX is when you also add external regressors to the model. So to be precise, when we did a lot of testing, what we ended up using was the moving average factor, because it's a very strong assumption to make that your sales yesterday affect your sales today, which is why we did not like the autoregressive factor, and we kind of ended up using the moving average factor in particular. And we are happy to report that the results were very similar to the country baselining approach when we actually tried it. So we kind of like alternate between these 2 approaches, and we most of the time get similar results. We use ARIMA mainly when we're trying to estimate a global activity, which is not specific to the US. Right, and that's it.